Hello guys, I'm a tutor here at REACH at the University of Louisville, and today we're just going to go over how to balance oxidation reduction reactions using the half reaction method. So first of all, you see a generic reaction where phosphate reacts with chromium to form chromium oxide and hydrogen phosphate. The half reaction method separates these two into two different half reactions. So we see the first half reaction would be where chromium goes to chromium oxide. And the second one would be for the phosphorus. All right, so the first step is always separate half reactions. And that's what we just did. Step two, and the rest of these steps you're going to have to do with each reaction separately. So step two is to balance everything but oxygen and hydrogen. So we'll do this in each of these half reactions. So on this side, we're not going to worry about the oxygen right now, but the chromium, there's one on this side and there's one chromium on this side, so we're good there. We just need one of these on each side. For the phosphate, the oxygens don't matter and the hydrogens don't matter. So there's one phosphate here, so we're also good in this reaction. So this step was unnecessary for this, balancing this redox reaction, but it may be needed for other ones. Step two is, the next step is going to be to balance oxygens using water. So in this case, there's two oxygen on this side, none on this side. So we'll have to add two waters on this side of the reaction to balance the oxygens there. On this reaction, we'll have to add one oxygen on this side, or one water on that side to balance the four oxygens here and only three oxygens over there. All right, the next step is to balance hydrogens using protons, so H+. So in this case, we have four hydrogens on this side, none on that side, so we'll add four H+ on that side. For this reaction, we have three hydrogens over there, none on this side, so we'll add three to this side. Okay. The last balancing you have to do is to balance charges using electrons. So let's do this. On this side of the top reaction, we have a net charge of 0. On that side, we have a net charge of +3 because we have a -1 here and a +4 here. So net negative or +3. So we'll have to add 3 electrons to that side of the reaction to where now that side is net 0 and this side is net 0. So the charges are balanced. For this reaction, we have 3 positives here, 3 negative charges here. So this side is 0. For this side of the reaction, it's a -2 charge. So if we had 2 electrons on this side of the reaction, now that is balanced. All right, so I'm going to erase these steps so I can put the additional steps on there. All right, so the next step is to add these two half reactions together. But when we do that, the electrons must cancel out from the opposite sides. And so we can see that there's 2 electrons here, but there's 3 electrons on this side. So we're going to have to multiply the top equation by 2, and so there's 6 electrons now, and the bottom equation by 3, and so there's 6 electrons here, so they will cross out. The second to last step is now just going to be to add the equations together. So what we'll see is there's 4 waters on this side. There's 3 on that side because this 3 times the 1 over there. That'll cross out with these. We'll be left with 1 water on the left side of the equation. Also, so basically we're just going to carry everything down now. Plus 2 chromiums. A good way to make sure you don't mess anything up for these is to cross things out as you write them down, and that way you can make sure that you properly have every reagent in the overall reaction. So the electrons crossed out. There's a total of 3 times 9 protons here and 8 over there. So we can cross these out and we'll be left with 1 on this side. And then the 3. And so I'll write the right side of the reaction on the bottom just to make it clear. All right. So a good way to check your answer, and I highly advise doing this, is to make sure everything is balanced in the final reaction. So this includes all non-hydrogens and oxygens, hydrogens, oxygens, and electrons and charge. So let's look at chromium. We have 2 on this side, 2 on the other side. So we're good with chromium. Phosphorus. We have 3 phosphorus on this side, 3 phosphorus on this side. So we're good there. Oxygens. 12 oxygens with this. 1 more here, so that's 13. On the bottom, we have 4 with this, plus 9, so that's also 13. Hydrogens, 2, and 1 more is 3. And on the bottom, we have 3. So we're good there. Last thing to check is charge. The charge for this side is 9 minus, and then we have a positive 1, so it's technically 8 minus charges. On the bottom, we have 3 2 minus, so that's 6 minus, plus another 2 minus, which is 8 minus also. So we're good leaving it here if the question asks to balance it in acidic conditions, because that's where H plus comes from. If we're asked to do it in basic conditions, there's one additional step. And so whatever you do to the left side of the reaction, you can do to the right side. And in our case, the right side is the bottom. So if we added 1 OH minus here, then we can add 1 OH minus to the bottom of the reaction. And so what that does is this OH minus and this H plus will react to form 1 water molecule. And so we can put 2 water molecules now, because we had 1 before and we just formed 1 when they reacted. And so now we're in acidic conditions because we had the reaction written with OH minus instead of H plus. And so all we had to do is add equivalents, enough equivalents of OH minus on each side of the reaction to balance out that H plus that we had right here. And now the reaction is in basic conditions. I hope that helped. Thank you.